Next is case 2 when your fx is a function of exponential of x. So since this is an operator method, so we are going to write y in the term of 1 over PD fx. And our PD, let me put it this way. If I have the differential equation like this, A1 and this one, if I write it in the term of operator D, I would get right? Now, I can say that my PD is equal to A0 times C to the power n plus A1 times C to the power n minus 1 plus an minus 1d plus an. So, what if I have PD times exponential of AX? What do I get if I have PD times exponential of AX? I said that I would have and if I just distribute the exponential term into every term inside the parenthesis, I would get and we know that if you have the exponential of AX, what do you get? The first derivative of exponential of fx, or of exponential of AX, A times exponential of AX. If I have the second derivative of exponential AX, what do we get? A squared exponential AX. If I have the third derivative of exponential AX, I would get A to the power 3 times exponential of AX. So if I have n minus 1, I would get what? A to the power of n minus 1 exponential of fx. Okay, and same thing if I have the n derivative of exponential ax, I would get a to the power n exponential of ax. From what I know here, it is plug in there. I mean in each term bracket, so I would get a0, a to the power n exponential of ax, a1 times a to the power n minus 1 exponential of ax plus until an minus 1 a exponential of ax plus an exponential of ax. Every term has exponential of ax, so I take it out, so I would get Now, if you compare the term of the term inside the parenthesis and the term of PD, it just looks pretty much the same, right? It's just that you change the D here into A. So I would say that this one we call PA. So by this definition, I would say that if I have 1 over PD exponential of AX, it would be equal to 1 over PA exponential of AX. But this one would be true if PA not equal to 0. So this is the one that we are going to use. And you might ask me, what if PA is equal to 0? What does it mean by that? If PA equal to 0, that means when you put A into every term of D in your PD and it is equal to 0, you cannot use this formula to find the function of 1 over PD exponential of AX. But what you can do is you can use this definition. Okay, now you have another two definitions for that. I'm sorry. PA is equal to 0. So if your PA not equal to 0, you use the first one. If your PA is equal to 0, you use the second one. Now, take a look at the example. This differential equation saying that you got to find the solution, so it is a non-homogeneous differential equation. So your solution is combined with yc and yp. Now we find yc first. Yc, got to write down the characteristic equation, which is m minus 2 to the whole thing to the power 5 is equal to 0. So you can find 5 value of m, which is 2 and 2 and 2 and 2 and 2. So yc is equal to c1 plus c2 x plus c3 x squared until what? Plus until what? X to the power x to the power 4, right? That is our yc, because our k is equal to 5, right? X to the power k minus 1, 5 minus 1 is equal to 4. Now find yp. I am going to use the shortcut method, and now if you take a look at it, the first term is in our second case. The second term is also in our second case. But the third term is a constant. Constant, you can take it as the first case or second case fine, because it seems to me that it's a 4 times x to the power 0, or 4 times exponential of 0x. Since every term of u is in exponential, I would take 4 as the exponential term. Okay. Because if you take it as the power term, you got to do dividing, so that means you got to distribute this term and then do some dividing in order to get b0 plus b1d plus blah blah blah, right? Okay, now I would say that my yp is equal to 1 over d minus 2 to the power 5. Okay. Now, for the operator, they have the distribution property, and the constant can be taken out from the operator side. Now, with the formula that I told you, it said that if, look at the first formula first. They said that if you have 1 over PD times exponential of fx, the value of this function is equal to 1 over PA. This one is a constant number times exponential of AX. What I mean by that? You've got to put the value of A into every single D term in your PD, and it shouldn't be equal to 0. Now, take a look at the first term. What is the number of A? 2. Then you plug 2 into the D. Now you have only D here, but when you put 2 here, 2 minus 2 equal to 0. So that means your PA is equal to 0. Can you use the first one? No, you can't. You got to use the second one. The second one is called your PA is equal to 0. And this one, your PA is equal to 0. Now, it says that if you have 1 over d minus a to the power m, you have d minus a to the power m. Now your m is equal to 5. It's saying that it's equal to x to the power m, which is x to the power 5 divided by n factorial. 5 factorial times exponential of ax. Now your a is equal to 2, so exponential of 2. That's it. So that's why it's called shortcut. Now, the second one, a is equal to 1. Now, a is equal to 1. It said that, we try the first one first. It said that if you put 1 into the d term inside your PD, it has this d. What do you get? You put 1 here, inside here you would get what? 1 minus 2 equal to minus 1. Minus 1 to the power 5 is equal to minus 1. It's not equal to 0, so you can use the first one. Minus 1 and minus 1 got plus 1. And the last term, your a is equal to 0. You got 0 there. 0 minus 2 has a value, has some number. It's not equal to 0, so you can use the first formula for that. You put d equal to 0 there, you got minus 2 to the power 5. Minus 2 to the power 5 is equal to minus 32. So that's it. That is our yp. So, the answer is y is equal to yc plus yp. That's the solution of this differential equation.